Good morning to our respective lecturer, IR Azri, and everyone. Today, we'll be presenting an operational and financial evaluation of Inotech Manufacturing Ltd, which is a mid-sized company specializing in energy-efficient HVAC system. These systems are mainly supplied to hospital and green certified building. So, as a part of its growth strategy, the company is preparing for a major expansion. However, they face the challenge of maintaining operational efficiency while scaling up. So, to support this transition, this assignment focuses on few key objectives, which is firstly, to evaluate the company's financial and operational readiness for expansion, and finally, to redesign the costing and budgeting system for better accuracy and control. So, the goal is to ensure that any future investment or production increases are both sustainable and profitable. To manage operational efficiency and financial performance at Inotech Manufacturing Ltd, it is important to understand how costs behave in relation to production. So, as we know, costs are classified into fixed, variable, and mixed. This helps the company to predict how expenses change with output. Firstly, fixed costs like factory rent. It remains unchanged regardless of production volume. And secondly, variable costs such as steel casing, assembly labor, electricity for testing labs, and equipment maintenance, it increases as the production rises. For example, more units produced means more steel and more labor hours. Furthermore, electricity consumption also scales with the number of HVAC units tested, making it a variable overhead. And finally, equipment maintenance costs grow with increased machine usage. So next, this table shows the estimated monthly values for each major cost item based on the production volume of 600 HVAC units. Firstly, steel casing is a variable cost estimated at 200 ringgit per unit, totaling to 120,000 ringgit. It is based on the current market prices for galvanized steel. Next, assembly labor is also variable, assuming 1 to 2 hours per unit at 75 per hour, giving 90,000 in total per monthly. Furthermore, electricity for testing labs is another variable cost, which is estimated at 7,000 ringgit based on the equipment usage during quality testing. Furthermore, factory rent, a fixed cost, is 30,000 ringgit calculated from the average lease rate for industrial facilities. And finally, equipment maintenance is 15 ringgit per unit, totaling to 9,000 ringgit, and includes routine servicing based on the unit usage. We move on to cost behavior graph. So this graph illustrates how fixed, variable, and total costs behave as production increases up to 600 units. Firstly, the orange line represents fixed costs, which remain constant at 30,000 ringgit regardless of the output. So this reflects costs like factory rent. And furthermore, the green line shows variable costs, which increase linearly with each unit produced, driven by inputs like steel, casing, labor, and electricity. And lastly, the blue line represents total costs, which is the sum of fixed and variable costs. So it starts at 30,000 ringgit and increases steadily as more units are produced. So this trend clearly shows that while fixed costs are stable, variable costs dominate total cost increases, which reinforce the importance of controlling unit-level efficiency as Inotech scales up. In the table, we classified the HVAC project costs as either direct or indirect, depending on whether they can be directly traced to individual units. So, firstly, we have steel casing and assembly labor. These are direct costs because they are clearly tied to each unit produced. The casing is a core raw material and labor hours are measurable per unit. So these fall under direct material and direct labor respectively. On the other hand, electricity for testing labs, factory rent, and equipment maintenance are all considered as indirect costs. This supports the overall production process, but it cannot be linked to specific units. For example, electricity is needed to run testing equipment but varies with the production volume. Other than that, factory rent is a fixed overhead. It stays the same no matter how many units are made. And finally, equipment maintenance may vary slightly with usage, but it generally applies across all operations. In this section, we look at different costing techniques used to calculate the production cost. As for Inotech's manufacturing, job order costing is the most appropriate technique. This is because job order costing allows tracking of cost per order, which helps to improve pricing accuracy and profitability analysis, which is also a key for Inotech's future expansion. This slide shows two approaches to job order costing for Inotech's HVAC project. The first table uses a standard costing method where overhead costs like electricity, rent, and maintenance are grouped into a single applied overhead rate of 76 ringgit 67 cents per unit. It simplifies tracking but doesn't show individual cost drivers. On the other hand, the second table breaks these costs down specifically, giving us a clearer view of where each ringgit goes. Now, let's break down the job cost using the specified technique. Firstly, steel casing, a direct material, costs 200 ringgit per unit. With 600 units, that totals to 130,000 ringgit. Next, assembly labor is calculated at 150 ringgit per unit, also for 600 units, giving us a total of 90,000 ringgit. For overhead cost, Electricity for testing lab is estimated at 7,000 ringgit and factory rent at 30,000 ringgit. And finally, equipment maintenance comes to 9,000 ringgit based on the 15 ringgit per unit. All of this adds up to a total job cost of 256,000 ringgit. When we divide that by 600 unit, we get a cost per unit of 426 ringgit 67 cents.
Hi, my name is Semi, and now I'm going to present about the budgeting and the forecasting for Innertech Manufacturing Ltd. During its first quarter of the expansion, budgeting helps the company plan and control its cost, while the forecasting it predicts the future performance using historical data and the expected demand. For this quarter, we assume the monthly sales of HVAC units are 400. Yes. Then the selling price is around 2,500 unit and the variable cost is around 1,600 per unit, where the fixed cost for the quarter are estimated at around 450,000. Then by using these assumptions, the total revenue over the quarter is projected to be 3 million, where all of these come from the selling of 1,200 units at 2,500 for each. The total cost is estimated at 2.37 million, where it is made up of the 1.92 million in variable cost and 450,000 in fixed cost. By subtracting the total cost from revenue, we get a projected net income of 630,000. This indicates that the expansion will be profitable under the given assumptions. And next, we conducted a break-even analysis to determine the sales volume needed to cover all of the cost by using the break-even formula, where the formula is the fixed cost divided by the selling price per unit minus with the variable cost per unit, where the selling price per unit is 2,500, the variable cost per unit is 1,600, and the fixed cost is 450,000. And then we insert the value and we will get like of around 500 units. This means that the Innotech must sell at least 500 units in the quarter to avoid any losses. Beyond that, every additional unit sold contribute 900 in profit, which is the remaining is like 700 units. Then we time with the 900, and the profit we will get is around like 630,000. Then we move to the graph, where the graph has two lines, where the blue one is represent the total revenue, and the orange one is represent the total cost. And we can see that the break-even points where the cost and revenue lines is intersect to each other at 500 units. And to the right is the profit zone where the revenue exceeds the cost. And to the left is the loss zone where the company would incur losses. That's all from me. Thank you.
Hello, my name is Professor Jeffrey Mukyong. My matrix number is PK221101118, and I will now be presenting my part on capital investment. So for my part, we are trying to evaluate and justify purchasing a new advanced robotic welding equipment at Innotech. To do that, we will have to do analysis and using costing budgeting techniques like NPV, net per value, and IRR, interest rate returns. Now, the details for this are the initial cost is 300,000 ringgit. The annual savings is 90,000. Project duration is 5 years, and the discount rate is 5%. Now, for the IRR method, the IRR method, or internal rate of return, is the interest rate that makes the net present value of an investment equal to zero. It helps show how profitable a project is by showing the rate of return needed for the investment to break even. So, the higher the IRR, the more profitable the investment is, or if the IRR is greater than the discount rate. Now, the formula for calculating the IRR method is taking the sum of this formula C in, which is just the net cash flow over 1 minus the IRR, or the internal rate of return, raised to the power of t, the time minus the initial investment. Now, it has been found that to make the entire formula equal to 0, the discount rate is 15.23%, looking at the table, please. So for NPV method, or net present value, it is a method used to decide if an investment is worth pursuing or not. It compares the money that I'm expected to make in the future, the cash inflow, to the money I would spend, the cash outflow, the expenses, investments, all that. Now, to decide whether or not the NPV is good or bad, if the NPV returns positive, then the project is expected to make more money than it would cost. So it is financially a good idea. But if the NPV is negative or below 0, the project would lose money. So it is not a good investment. Now, to calculate the NPV, we use the formula C in over 1 plus dr raised to the power of t. T is the time, C in is the cash flow, and dr is the discount rate, which is the interest rate used to figure out how much future money is worth today. Now, plugging all the numbers in with the details we've applied, laid out over a period of 5 years, we can get a total sum of 341 and 169 ringgit. minus the initial investment, we get 41,169 ringgit, which is positive. So this is a financially sound investment. Now, before we propose a solution, it's best to break down the types of inventory at Inotech. First one, raw materials. It is a basic material or substance that are being transformed into finished good. Things like steel, water, clay, stuff that is being transformed into something more useful. Now, the drivers for this, the drivers for the demand is the required materials needed for the finished goods. Next are the maintenance, repair, and overhaul, or MROs. These are the supplies used when machineries undergo maintenance. So spare parts for a car, like the oil change for a car, or replacing the gears and nuts of a machinery so that they are at good working capacity. Now, the demands for the drivers are the mean time between failure for an equipment or the average time for equipment before failure. Next, work in progress or WIP. These are the raw material that have been processed but have not been fully completed. The drivers of this demand are customer orders, and finally, finished goods. These are the final product at the end of the manufacturing process. The demands for the drivers are customer orders. Now, one of the ways we can fix the issues at Inotech, and specifically the work in progress backlog, is just-in-time system. A just-in-time system is a system that only starts production when there is a demand. So we order the raw materials and only use them when it is needed. The benefits of this are that we don't have to have a large amount of inventory, so we can also save on storage costs because of that, as well as reduce waste due to not needing as much inventory. An issue with this is that it is very vulnerable to supply chain disruption since we don't have inventory buffers. So in the event that there is supply chain disruption or the suppliers do not have the materials we need, we are going to have delays. This does require us to have a good amount of planning and a reliable supply so that the above issues cannot occur. Now, finally, to solve the inaccuracy for the inventory, implementing a perpetual inventory system would be beneficial for Inotech. A perpetual inventory system is a real-time tracking system that uses digital systems and scanners to track the materials. So there will be a sort of scanner putting a barcode on the material, scan once it's done, put it in a system, and now we have the materials quantity in a lodge. The benefits of this is that it has instant updates for all inventory types: raw materials, work in progress materials, final goods, and MROs. This helps enhance the accuracy, reducing errors. So we don't have to double check whether or not this is the correct number or not. We can just simply know from the data. Now, the challenges of this is that it does have a high setup and training cost. We do need to set up a software, a server to store all the data, and set up the hardware so that we can track the materials easily and instantly, plus training the staff as well. It does require a skilled staff, so more training and teaching them, plus a reliable software so that there will be less errors.
I'm Phil Janal, and let's start with why KPI are so important for Inotech manufacturing. Inotech is expanding into important markets like hospital and green certified building. These clients expect high quality, reliable product, so Inotech can afford to guess how well it's doing. That's where performance measurement comes in. It's not just a helpful tool, it's absolutely essential. By tracking the key engineering KPI, Unitech get real-time insight on how their operations are running. This helps them to spot problem early, improve where needed, and make sure every part of the production support their growth and financial goal. So, in simple terms, good data leads to a smart decision, and smart decision lead to success. So let me walk you through this table of key engineering KPIs that are important for the Innotech engineering. So first one, total unit produced. This KPI track how many Econ units are completed in a specific time frame, monthly or quarterly. It helps the company to assess its production capacity and ability to meet demands, especially during period of growth. For example, producing 1,000 to 200 units in Q1 means they are on track with the expansion target. So two, cost per unit. It shows how much cost to produce one aircon unit. By keeping costs low, Inotech can increase its profit margin per unit, assuming the selling price stay the same. Managing this effectively support financial goals like increasing net income and stay competitive in the market. Okay. Now we go to the three. Downtime percentage. This measure how much time equipment is not operating compared to the total available time. High downtime means lost productivity. Reducing downtime, especially with expensive machinery like robotic welder, lead to more efficient use of resource and lower fixed per unit. So let's go on to the fourth one, defect rate. This track the percentage of unit that fail quality check. A lower defects rate means less rework, less material loss, and fewer warranty issue. This also help build a reputation for quality, which is especially for important serving sensitive sector like healthcare and green certified building. Okay, OTD or on-time delivery. This measure whether the customer order are delivered as promised. Consistently hitting delivery target, build customer trust, strengthen long-term relationship, and avoid penalties. It also supports repeat business and overall brand reliability. In short, these KPIs help Innotech connect an operational performance with financial outcome. By monitoring them closely, the company can improve efficiency, support strategic growth, and profitability. This now, let's look at how each KPI directly connect to Innotech financial performance and strategic goal. So let's look at the first one. When the cost per unit goes decrease, the profit increase. This means when the company lower actual mass cost to make each unit, it earn more from its sale. For example, if the price sale stay at 2,500, cutting production costs help them reach the net income of 630,000 for Q1. So let's move on to the second one. Downtime goes decreases, revenue increase and cost decrease. Less downtime means machine are working more, reducing more unit that lead to higher sales rate, like their 3 million Q1 revenue goals, and more efficient use of fixed costs like factory rent or equipment. So when the detect rate goes low, it saves the cost saving and cost and increase the customer trust. Fewer detected product mean less money spent on rework and fewer warranty claims. Plus, high quality product build trust, especially important when selling to hospital and state market. On-time delivery increases, it means customer loyalty and sales growth. When products are delivered on time, customers are more likely to come back and recommend the company. But if there's a delay, it could mean penalty or losing future businesses. Okay, when the total unit produced increases, the market readiness and growth also growing, hitting or beating the production goals so that Innotech can scale up the operation. This support long-term growth and help them to capture more market value while increasing ROI. So these aren't just performance numbers; they are directly tied to how Innotech grows, start for people, and earn customer trust. Next, start expanding into more important market like hospital and eco-friendly building, managing project costs becomes super important. It's not just about sticking to the budget, it's about making sure the company actually make a profit it's aiming for and get a good return on its investment. For example, they are targeting 630,000 in profit for Q1, and they have spent a lot of new tech like robotic welding machine. So they really need to keep a close eye on how they are spending during this expansion. By tracking the cost properly, Innotech can avoid overspending, make smarter decisions, and stay financially healthy. This helps them grow sustainability and deliver high quality product to demanding client. Had laid out a clear cost baseline for its expansion project, which basically means they are planned how much money they will spend on and when. This helped them to stay organized and avoid going over budget. The project is split into four main parts. Facility renovation, which 1.5 billion from January to March 2025. Robotic equipment procurement and installation, 1 million from February to April. Assembly line upgrade, 800,000 from March to May. And training and commissioning, 200,000 to from April to June. Altogether, the total budget is 3.5 billion. If everything goes off track, like spending more than the plan or delay, tech management will step in to figure out what went wrong and fix it. This is the cost baseline act like a financial roadmap to keep the project on course. Use something called as earned value management or EVM to keep track of how their project are doing. It's helped them to compare three important things: what they plan to do, what they actually done, and how much it's cost so far. Here how it's work. Plan value or PV is a budget for the work they are supposed to finish by now. Earned value, EV, is the budget for the work they are actually completed. And actual cost, AC, is how much they really spend to get the work done. So from this calculative, they are calculative a few metrics. Cost variance, CV equal to EV minus AC, is positive, they are under budget. If schedule variance, SV equal to EV minus PV, is positive, they are ahead of schedule. Cost performance index, CPI equal to EV dash AC. If it's more than one, they're spending money efficiently. Schedule maintenance performance index, SPI, EV equal EV dash PV. It's more than one day they are working faster than planned. This system gives Innotech a clear picture on how well the project is performing in terms of both money. For example, Innotech used earned value management to check how the robotic welding equipment installation was going by the end of the March 2025. Here was the thought. The plan to complete 75% of the work by March, which equal to 750,000 is budgeted value or planned value PV. They only finished at 60% of the work worth of 600,000 earned value EV, and they spent around 700,000 to get 60% net. So using this number, they calculated that the cost variance is negative 100,000, which they are over budget. So the schedule variance is negative 150,000. They are behind the schedule. The cost performance index say that showing point of 0.86. It means they are spending more than they should. And schedule performance index SPI say that the SPI is 0.8. So it say that they are working slower than planned. So this example how EVM help Innotech to spot problem early and make action to fix them before things get worse.
Good day everyone, today I'm going to present the analysis for in-house production. The total annual cost for producing in-house is 3,264,024 ringgit. This cost includes several key components, which is 1,440,000 for raw materials, 1,080,000 for direct labor, 108,000 for machine maintenance, 84,000 for utilities, and 552,024 ringgit for overhead expenses. Beyond the financial figures, we also evaluate non-financial consideration. In-house production offers high-quality control, ensuring consistent product standards. It also provides high supply chain flexibility, which allows quicker response to changes in demand. For a workforce perspective, the implications are positive, supporting local employment and skill development. Lastly, the intellectual property risk is low since the process and knowledge remain internal. Although the cost is relatively high, in-house production gives the company more control, reliability, and long-term strategic value. Now, I will explain the outsourcing scenario, which we assess using an expected monetary value approach to capture risk and performance variability. There are three possible outcomes. First, high performance has a 50% probability with a financial impact of 8,735,976 ringgit Malaysia, giving a weighted value of 4,367,988 ringgit Malaysia. Second is moderate for performance with a 30% probability and a financial impact of 4,115,183 ringgit Malaysia, resulting in a weighted value of 1,234 ringgit 1,234,555 ringgit Malaysia. Lastly, poor performance has a 20% chance with a financial impact of 2,367,988 ringgit Malaysia and a weighted value of 473,598 ringgit Malaysia. The total expected monetary value or EMV is 6,076,141 ringgit Malaysia. Although outsourcing may appear more cost-effective compared to in-house production, it produces uncertainty and performance risks. Additionally, non-financial risks such as lower control, reduced flexibility, and higher intellectual property exposure must be weighted. In conclusion, our analysis supports Innotech manufacturing expansion into critical markets like hospitals and green certified buildings. We identify job order costing as the most suitable method for their custom HVAC production. Financial forecasts show a strong outlook with a project quarterly profit of 630,000 ringgit Malaysia and a break-even point of 500 units. Capital investment in robotic welding was found financially viable based on NPV and IRR analysis. To address inventory issues, we recommend the just-in-time system and a perpetual inventory method. Key performance indicators such as cost per unit, downtime, and defect rate were proposed to align operation with financial goals. For cost control during expansion, we suggested earned value management and project tracking tools. Lastly, strategic decision-making tools like cost-benefit analysis and decision trees were used to evaluate outsourcing option. These strategies position Innotech for efficient and sustainable growth.